Chapter 9, questions 7 and 8 deal with the solubility of solids and gases at different temperatures. So when you take a solid and you put it into water, one of the reasons why it dissolves is because the currents of water knock into the solid and scrape it. They crash and bang into the side of the solid. Even a glass of water that seems like there's no motion in it, nothing's happening, actually has hundreds of thousands of little currents and water molecules constantly scratching and scraping against each other. When you put a solid in it, suddenly the water molecules start scratching and scraping against the solid, then the solid starts breaking apart into tiny, tiny little pieces. And so that's how a solid dissolves. Now, at higher temperatures, At higher temperatures, the water molecules crash and bang into the solid more forcefully and more often, and so the solid dissolves better. Temperatures. So the solid dissolves more. So solids are more soluble. They dissolve better at higher temperatures. So solids are more soluble at higher temperatures. Okay, what happens when you put a gas into a container? Well, a gas can be dissolved in a liquid. That may not seem as intuitive, but for example, if you've ever opened a soda bottle or a champagne bottle and heard the pop or the fizz, that fizz is coming from a bunch of gas that was dissolved in the liquid. And when a gas is dissolved in a liquid, it's dissolved in lots and lots of tiny little bubbles. As at a higher temperature, those bubbles get knocked around really, really hard, so the water molecules push and pull on them and knock into them and push them around in a violent way. And the higher the temperature, the more violently the water pushes those bubbles, and the more often they will hit the top of the water. And whenever the bubble hits the top of the water, it pops. So at higher temperatures, bubbles will reach the top of a liquid more often, and they'll pop, and the gas will be less soluble. So gases are just the reverse of solids. Gases are less soluble at higher temperatures. So that's gases. Now think of an implication of that. We have gases in the air all the time, things like oxygen. And then we have, especially in South Florida, lots of water around, the ocean. The oxygen in the air is constantly being pushed down by the weight of the entire atmosphere above it. And that being pushed down lets the oxygen dissolve in the ocean. That's the oxygen that fish breathe. But at high temperatures, like there are in South Florida or in tropical areas, at high temperatures, not a lot of oxygen can dissolve. And so, tropical places are sort of the deserts of the ocean. More oxygen can dissolve in colder areas like the poles, and that's why there's so much krill and shrimp at the poles, and why creatures like humpback whales go to the poles to eat, or why there's such a diversity of life. There's so many nature documentaries about the poles, because so much oxygen can dissolve in the water and support more life than in tropical areas. So, solids dissolve better at higher temperatures, and gases dissolve better at lower temperatures. And so that principle will help us to explain the observations in exercise 7 and 8. So for 7, it says, explain the following observations. A, more sugar dissolves in hot tea than in iced tea. So the reason for this is that sugar is a solid, and the principle we just saw is that solids dissolve better at higher temperatures. Okay, B, it says champagne in a warm room goes flat. Flat champagne is champagne that doesn't have any bubbles in it anymore. So all of the gas that's dissolved in it, which is carbon dioxide, has escaped. So why? Well, The bubbles in champagne are a gas? And gases are less soluble, dissolve worse at higher temperatures. C, it says a warm can of soda has more spray when opened than a cold one. And this is a fun experiment. If you take 2 Coke cans and you leave one out, so it's room temperature, and put another one maybe in the refrigerator for a couple days, shake them both up and open them, you'll see the one that was warmer has much more spray and explodes much more than the colder one does. In other words, the gas is less soluble in the warmer one. So this one has a similar explanation as the previous. The spray is gas, and gases are less soluble at higher temperatures. So the spray is gas, and gases are less soluble at higher temperatures. That's why a warm, aka a higher temperature, soda has more spray escaping, more gas escaping it. Okay, how about 8A? An open can of soda loses its fizz faster at room temperature than in the refrigerator. So the fizz here is gas. And gases are less soluble at higher temperatures. That's why at higher temperatures, the gas would escape the soda, and so the soda would lose its fizz. Okay, B, chlorine gas in tap water escapes as the sample warms to room temperature. And so this is the same idea. Except instead of fizz, like the last time, you'd say that chlorine gas is gas. And gases are less soluble at higher temperatures. And so the gas would escape the water as it warms. All right, C says less sugar dissolves in iced coffee than in hot coffee, so you can make the coffee sweeter if it's hot than if it's cold. So less sugar dissolves. Why? Because sugar is a solid, and solids dissolve better at higher temperatures. So these are a bunch of observations from daily life, and you can see that they are derived from this principle we saw before, that solids are more soluble at higher temperatures and gases are less soluble at higher temperatures.